However, some black holes are more interesting than others. For example, if a star is found near a black hole, he will begin to be torn apart by the attractive forces of the black hole. On a timescale of millions of years, the material from the star starts orbiting the black hole, is sucked away and forms a suction cup. The sucker may take 1 to 1 billion years to be fully absorbed by the black hole. Before that, matter will merge into a flat ring around the black hole's world. Due to the conservation of momentum, it's not going to fall in. In this case, we're talking about angular momentum. Because the disk rotates, we will use 805 actors as an example. Ballerina extends her arms. Rotate at a point. If a ballerina suddenly brings her arms close to their bodies, what will happen? Intuitively, he will start spinning faster, precisely because the hands of Parisian dancers carry angular capacity. When the arms are extended, momentum in the hand moves at a certain speed. And when the ballet dancer folds his arms, momentum is still trying to maintain this speed, but now the path of movement of the hand is much shorter, because he spins at the same speed. So ballerinas spin faster. It's a classic example of conservation of agitation. The beauty of physics is that the results are fairly universal. They can be applied to both large cosmic scales. It can also be applied to small scales. The matter surrounding the black hole orbits in an inspiratory disk, captured by the attractive force of the black hole. Conservation of angles is always happening. Once the substance approaches the center, he will accelerate, moving at the same speed in smaller orbits, like in the case of the ballerina. This is what happens when matter spirals towards the center of a black hole. So you have to imagine that the substance was stolen from the other one, sucked away and spiraled in. The black hole accelerates to relativistic speeds as he does. The roosting disk material finally reaches a point. He can't go any faster. Due to the limitations of the speed of light, he hit a roadblock. At this level, collisions and frictions heat up matter around the world. Everything became very hot. Temperatures can reach 10 million Kelvin. When this happens, atomic collision. These collisions cause them to release more and more atomic mass. Convert it into energy. According to Einstein's famous law, 1 equals mc2 squared. Scientists believe that 10 to 40% of an atom's mass is released this way in the form of energy. Because this energy emission, suction cups were observed to be very, very bright. But how bright can it be? The brightest disks are called quasars. They can be more than 1,000 times brighter than the sum of all the horizontal rows in the Milky Way galaxy. But what's even more interesting are a handful of supermassive black holes. A massive black hole lurking at the center of a galaxy, also known as a quasar, emitting ion jets at the speed of light as they engulf. Astronomers don't know what powers the jet stream, but they think the jet is powered by the black hole's coupling to the roosting disk. About how jets are formed, the most popular explanation is that the fast-spinning suction cup will generate the powerful magnetic field underlying the black hole. If the black hole is rotating, he will drag the magnetic field, wraps into a tight cone at the black hole's rotating pole. It's this twisted magnetic field that accelerates ions away from the black hole in jets and extract energy from the black hole's rotation in the process. So in summary, scientists believe that falling into a black hole is possible, but that's not the only way. It's also possible not to fall into it. There are many ways a black hole can destroy you. You are likely to die from the heat generated by spinning in the suction disk. If you reach the starting point, may be broken, or you could be part of a plasma jet that's being injected into space at relativistic speeds. I advise you to stay away from the black hole under any circumstances. What do you have to say about that? Please leave a message in the comment area below. The video ends here. Thanks for watching. See you next time. I have some bad news for you. That is, a component of the James Webb Space Telescope has been temporarily discontinued. NASA announced, the James Webb Space Telescope has discontinued one of 4 observation modes using the mid-infrared instrument. And the reason they're closed is because there's increased friction in preparation for the observations. The announcement was made on September 20th. Air traffic controllers first noticed the problem on August 24th. No one likes to see problems with space telescopes. especially when we're talking about the James Scarf Telescope. But project leaders say it won't be a long-term problem. Let's take a closer look. After that, we will also see new photos of Neptune and Mars taken by the scarf. Let's go and have a look. One of the 4 observation modes of the mid-infrared instrument on the James Webb Telescope. The mechanisms that support this observation pattern then exhibit increased friction during preparation for the observations. Is that as bad as it sounds? To understand him, we have to take a step back. Take a look at what a camera outside China is and how it works. This amazing camera is at the heart of the James Webb Space Telescope. He opened our eyes to a universe we had never seen before. Our eyes cannot see in the infrared region of the electron spectrum because its wavelength is longer than what our eyes can see. But mid-infrared cameras can be used this way. His sensitive detector allows us to see the red fluorescence of distant galaxies, newly formed stars, and very faint visible objects, such as comets and objects in the Cobb Belt. This is what mid-infrared cameras can do. But to understand the problem with the James Webb Telescope, we need to know him better. The 4 observation modes of mid-infrared everything are imaging, first resolution spectroscopy, solar immunity imaging, and moderate resolution spectroscopy. NASA explained that this is a kind of light mountain wheel. Scientists can choose between short, medium, and long SOWs when using this mode for observations. Engineers are still trying to identify the root cause of the problem. They may need some time to resolve all issues. In this case, the smartest thing to do is to turn off the observation mode of interest at the International Astronautical Congress on September 21st. NASA says they're taking steps just to make sure it works. Everybody was pretty confident it wouldn't be a big problem, and it will be resolved soon. The engineers who took it down had previously successfully solved problems and malfunctions on the Voyager probe. The Voyager probe is the most distant man-made object ever built. So I'm pretty sure they'll soon find a solution to the James Webb Telescope problem. It might just take some time, because everything has to be done from a distance. Unlike the Hubble Space Telescope, NASA was unable to send a team into space to repair the James Webb Telescope. Because Hubble is in orbit around the Earth, this made it possible to launch the space shuttle. But the James Webb Telescope is much farther away, about 160 million kilometers. He is so far away, so much so that he doesn't actually orbit the Earth. It orbits the Sun, so physical repair is not an option. The SCARF team will have to solve this particular problem remotely. However, all other observation models worked as expected. The James Webb Telescope continues to operate in other ways or exceeds expectations. During the International Astronautical Congress, the mission released a stunning image of Neptune. This is actually from the Voyager 2 spacecraft in 1989. The most detailed observation of him since flying over this distant planet. Aquaman's heart has fascinated researchers since it was discovered in 1846. He is 30 times farther from the Sun than the Earth, and he travels in the distant, dark regions outside our solar system. If you look at the Sun from Neptune, he's nothing more than a small, dark disk. Noon on Neptune is similar to dusk on Earth. It's also very cold. Due to its internal chemical composition, it makes sense for the planet to be described as an ice giant. Compared to the gas giants Jupiter and Saturn, Neptune's elements are much heavier than blue and sea. This is visible in the Hubble Space Telescope image. The wavelengths of Neptune's signature blue appearance are evident in the fact that they are caused by small amounts of gaseous methane. Hubble and Weber work in 2 different wavelength ranges. This is why Neptune doesn't look blue at all in Webb's image. In addition, if you are not an astronomer, you might be wondering why Webb's image shows Neptune's rings. Hubble doesn't. This is because most of the light coming from a planet's rings is emitted in the infrared region of the electromagnetic spectrum, so Webb's path is better suited for this purpose. This is the most detailed picture we have of Neptune's rings. There are some halos in this image that we've never seen before. Methane gas absorbs red and infrared light very strongly. So much so that the Earth is quite dark at these near-infrared wavelengths. Unless there are high-altitude clouds, the form of bright streaks and spots highlights this methane ice cloud. They reflect sunlight before it gets absorbed by the methane gas. The bright thin line that you see around Neptune's equator may be a visual feature of global atmospheric circulation. This circulation powers Neptune's winds and storms. The atmosphere drops and warms at the equator, emitting light in infrared wavelengths. The orbital period of a daylighting star around the Sun is 164 years. That means for now we can't see its north pole. But the image of the scarf suggests that at the top of this image, this area has an interesting brightness. But it's not just Neptune in this picture. For example, do you see that bright object in the upper left corner? What was it? That's Neptune's moon, the sea sweater. So this is a very bright blip. It has the iconic ocular spikes seen in many images of the scarf. Number 1 is an unusual satellite. They are covered in a frozen sheen of condensed nitrogen. On average, 70% of the sunlight reflects off him. That's why he looks so bright in images from near-infrared cameras. In fact, in this photograph, his light far surpasses Begonia's star. So why is that? This is because the planet's atmosphere is darkened by methane absorption at near-infrared wavelengths. Triton has a very complicated history. Dynamicists believe that this moon was originally a scientific belt object. It was eventually captured by Neptune due to attractive force and non-attractive force. This might explain why Triton orbits Neptune in an unusual reverse orbit. Speaking of Neptune's rings, this picture is amazing. From the outside in, we can identify the Adam's rings, the 5 most studied major rings on Earth, named after John Couch Adams. He predicted the position of Neptune from Leverrier. Then the Arago ring, Russell ring, Le Vieux and Gala rings. The Gala ring commemorates John, who was the first person to look at Neptune with a telescope in 1846, named after Gottfried Gala. It is only 1 degree away from the position calculated by Leverrier and Adams.